Sliding of a chain on a horizontal table. Sliding on a chain on a horizontal table. See here, length of the chain it is, first I am writing it is mass of the chain, mass of chain is equal to small m, and length is capital L, isn't it? In this situation, see here, weight of the object, hanging part it is 1 by nth of total mass is 1 by nth part of total mass is 1 by nth part of total mass is hanging. So 1 by nth part of the total mass means weight of the object is equal to weight of hanging part. Weight of hanging part it is mg divided by n. Weight of hanging part it is mg divided by n. Okay, I am writing here weight of hanging part is equal to mg divided by n. Weight of hanging part it is equal to mg divided by n. And what about the weight of the chain which is lying on the table? The weight of the chain which is lying on a table. So weight of chain which is lying on a table is equal to, see here, total weight of the chain. You don't know actually how much quantity of the chain it is lying on the table, but you know it is 1 mg by n weight of the chain it is hanging. Total weight it is equal to, for example, total weight is the mg, and if I subtract it from mg by n from the total weight, I can get the weight of the chain which is lying on a table. Total weight of, just I am subtracting mg by n, hanging part of the chain from the total weight of the chain. At that moment I can get the weight of the chain which is lying on a table. So that is equal to mg minus total weight of the chain it is mg, and hanging part of the chain is nothing but mg by n. Then if you take the common mg, you can write 1 minus 1 by n. Now here, starting, if the chain it is, because of the weight, it is moving, try to move downward direction. That is, chain it is ready to slide. If you taken here, frictional force is opposing the motion of the chain. Because of its weight, the chain it is ready to slide from the table. At that moment, frictional force opposes the motion of the chain. So the static frictional force is acting. Between the table and chain. So the static frictional force is balanced by the weight of hanging part. Because of this weight only, the chain it is ready to slide. So that's why only the frictional force is balanced by the weight of the chain which is hanging part. I am writing the equation, it is frictional force, static frictional force is equal to mg divided by n. Now what is the static frictional force formula? Mu s into n. That is equal to mg divided by n. And see here, from this one, there is a contact. See here, normal force we have to write here. What is the normal force? A force exists when two objects are in contact which is perpendicular to the plane of contact. See here, a force exists. One force is exist when two objects are in contact. Here table and chain is in contact. Two objects are in contact and which is perpendicular to plane of contact. Now this is plane of contact. Where the two objects are in contact, that we can call it is plane of contact. Now this plane of contact and these two are perpendicular. Here this is plane of contact direction and this is force direction. Both are perpendicular. So this is normal force. And weight of the chain which is which is lying on a table, that is downward direction, that is how much? mg minus mg into 1 minus 1 by n. Correct or not? So n is equal to, it is not accelerating up and down, it is not accelerating. So n is upward force is equal to downward force, you can write. N is equal to, you know very well, mg into 1 minus 1 by n. If you substitute in this equation, mu s into mg into 1 minus 1 by n is equal to mg divided by n. Both side mg get cancelled. Now I am writing mu s into LCM is n minus 1 is equal to 1 by n get cancelled here. Then mu s is equal to 1 divided by n minus 1. The coefficient of static frictional force between the chain and length, chain and table is equal to mu s is equal to 1 by n minus 1. If n is equal to capital L by small l, length divided by length of the chain divided by hanging part of the length, if I am taking, at that moment mu s is equal to 1 divided by capital L divided by small l minus 1. You can write here mu s is equal to 1 divided by LCM is L, capital L minus L, L goes to numerator, so mu s is equal to L divided by L minus L. Mu s is equal to L divided by L minus. Now again it is the connecting bodies, we are discussing about the connecting bodies. It is the frictionless pulley. This is frictionless pulley. I am taking two bodies are connected by string, and the string it is passing over the frictionless pulley, and this one it is mass m1 and another one it is mass m2. We are taking it is m1 is greater than m2. Mass of first object is greater than mass of the second object, isn't it? Now weight of the object, this weight is more means the object will move downward direction. When it is moving downward direction, this object is moving towards the pulley. Okay, fine here. And we are taking, this is the rough surface. It is rough surface, isn't it? Okay. Now what is the acceleration of the blocks? We are going to calculate. Okay. For this one, I am taking free body diagram of M1. First, I am writing here M1. It is connected to the one string. M1 is connected to the string. We know very clearly, tensional force is always away from the object. See here, tensional force is always away from the object. Given it is the symbol, it is upward, means it is away from the object. And weight of the object is acting downward direction. Now this block is accelerating up downward direction or upward direction. It is accelerating downward direction because the object is moving downward. When object is moving downward, acceleration of the block is downward direction. Now we are writing here what is the resultant. We have to write one equation, unbalanced force equation. Now resultant force is equal to downward force minus upward force. Why how to write downward force minus upward force? Because the object is moving downward direction. When object is moving downward direction means the downward force is greater than the upward force. So that's why resultant force means greater force minus lesser force. Resultant force is equal to greater force minus lesser force. Here greater force is nothing but a m1g and lesser force is the tensional force. Here greater force minus lesser force. Okay, resultant force is equal to, according to the Newton's second law, you can write m1g minus t. Now this is equation number 1. I am writing it is equation number 1. Okay, go for the second one. Here. This equation it is, this block is m2. So here it is connected to the one string. and tensional force is acting away from the object. tensional force is away from the object. See here, frictional force is acting, frictional force. See here, when object is moving towards like this means frictional force opposes the motion of the body. Frictional force opposes the motion of the body. So that is kinetic frictional force we have to write. Why we have to write kinetic frictional force means the object is already in the motion. When object is at rest position, static frictional force will be act. When object is in the motion, kinetic frictional force will be act. When object is rolling, rolling frictional force will be act. See here, the object is in the motion, so that's why opposing force is the kinetic frictional force. Now it is accelerating towards right or left? It is accelerating towards right side. So accelerating towards right side. Resultant force is equal to tensional force minus frictional force. Tensional force minus kinetic frictional force. Greater force minus lesser force. Resultant force is equal to, according to Newton's second law, ma. Here mass is m2, so that's why I have written ma. T minus mu k is equal to, what you can write? Mu k into n. Kinetic frictional force is equal to, what is kinetic frictional force formula? Fk is equal to mu k into n. What is n value? N is equal to, see here, normal force is acting upward direction. Normal force is acting upward. Weight of the object is acting downward direction. Normal force is upward. Normal force is always perpendicular to plane of contact. This is plane of contact. See here, where the two objects are in contact, that we can call it is plane of contact. So this is plane of contact. Normal force is always perpendicular to plane of contact. Weight of the object is downward direction. So N is equal to, upward force is equal to downward force. N is equal to mg, I am writing m2a is equal to T minus mu k into mg. That is equation number 2. That is equation number 2. From this equation 1, I am writing T other side and m1a this side. T is equal to m1g minus m1a, and it is equation number 3. Substitute equation number 3 in equation 2. At that moment, what you can write? m2a is equal to, here T is nothing but m1g minus m1a, m1g minus m1a, mu k minus mu k mg. Okay, this acceleration I am taking this side, m1a plus m2a equal to, this one I take in this side as remaining as usual, m1g minus mu k. What about this is? This is m2. This is m2g. So m2g mu k into m2g. Now in this one, what you can take common? A. m1 plus m2 is equal to g into m1 minus mu k m2. Then acceleration is equal to m1 minus mu k m2 divided by m1 plus m2 into g. Acceleration of the blocks is nothing but a equal to m1 minus mu k m2 divided by m1 plus m2 into g. Coming to rest on a horizontal surface. See here, one vehicle coming to the rest on a horizontal surface. Okay, one object is moving with a velocity v. Initial velocity is nothing but a v. One vehicle is moving with a velocity v. After covering some distance, it comes to rest position. The vehicle comes to rest position, isn't it? The vehicle comes to rest position. So final velocity is nothing but a final. We can write here, otherwise for your understanding, velocity, initial velocity is u. Finally it comes to rest position. So that is nothing but a v equal to 0. So what is the distance covered by the object? What is the distance covered by the object from here to there? We have to calculate. How we can calculate this equation? Any one of you. See here, they given very clearly initial velocity initial velocity is nothing but a u. Finally, final velocity of object, final velocity is equal to 0. Final velocity is equal to 0. Okay. Now, we can write here v square minus u square is equal to 2as. V square minus u square is equal to 2as. Now, in this situation, v square, it is nothing but a final velocity. Final velocity is equal to 0. Final velocity is 0. Initial velocity is the u I am writing, that equal to 2. What is acceleration? Acceleration is equal to, here we can write like this, mu s is equal to, F is equal to, frictional force is equal to ma. And this frictional force is equal to, you know, formula, it is mu into n. And frictional force is balanced by the Newton's law formula, F equal to ma if you taken, n is equal to, you know very well, mg, get cancelled, a equal to mu g. A equal to mu g you can write. So acceleration is equal to, see here, while it is moving from this point to this point, what is the velocity is gradually decreasing. When it is gradually decreasing, it is the negative acceleration. So that's why I am writing it is the minus mu g into s. Both sides minus minus get cancelled. U square is equal to 2 mu g s. So then s is equal to, you can write here, u square divided by 2 mu k into g. Here why I written mu k means the object is already in the motion. Object is already in the motion. Same concept I will explain in terms of the work energy theorem. Same concept I can explain work by using of the work energy theorem. What is work energy theorem? Change in work is equal to change in kinetic energy. W is equal to final kinetic energy minus initial kinetic energy. Work done is equal to, I am writing here, Fk into force into displacement. So force is nothing but a kinetic frictional force and displacement is the S. And final kinetic energy is nothing but a half mv square. Initial kinetic energy is nothing but a half mu square. Isn't it? Now I am writing here, Fk is equal to, what you can write? Fk is equal to mu into, Fk is equal to mu k into n. Kinetic frictional force formula mu k into n. And displacement is s, that is equal to half m v square minus 0. Because initial velocity is equal, final velocity is 0. So that's why v is equal to 0, you can write v is 0. Because the object finally comes to rest position, means this total part will becomes to 0. 0 into v equal to 0. 0 into something is 0 minus 1 by 2 m into u square. Okay, fine. Here S is, we need to find out mu k. What is n is equal to? N is nothing but a. See here, normal force is acting upward direction. Weight of the object is acting downward direction. So normal force is always perpendicular to plane of contact. So normal is upward, weight of the object is downward. Normal force is balanced by the weight of the object. So n is equal to mg. N is equal to, this n is equal to, we are writing mg. S is equal to minus 1 by 2 mu square. Here m get cancelled. We can write S is equal to, you can write here u square divided by 2 denominator and mu kg, I am taking this side, means mu kg. Here minus is there. Here what is the indication of the minus? Means it is in the opposite direction. Frictional force opposes the motion of the body. So here it is distance, if you consider, you can write it is the positive. Displacement means minus, you can write it is. So S is here, those formulas are same. By using of the work energy theorem I given, and by using of the equation of the motion I given. And what is the time covered? What is the time taken from point A to, from this point, what is the time taken by the body to reach point B position? Now in this situation I am giving it is the impulse is equal to change in momentum. Impulse. What is impulse? Impulse is nothing but a j, and change in momentum is nothing but a delta p. So impulse is equal to, what is impulse? A large amount of the force. A large amount of the force is applied in a short interval of the time is called impulse. Impulse is equal to, you can write here, force into time interval. impulse is equal to force into time, and change in momentum is equal to final momentum minus initial momentum. Change in momentum is equal to final momentum minus initial momentum. What is final momentum means? It is the product of mass and velocity. So final momentum minus initial momentum. Okay, it is nothing but a kinetic frictional force I am writing, because the object is in the motion. So kinetic frictional force. What is the kinetic frictional force formula? Mu k into n. Kinetic frictional force is equal to mu k into n. Time is t. That is equal to final velocity. What is the final velocity of the object? Is 0. Final velocity of the object is 0 minus m into initial velocity u. They are given very clearly. Mu k n. N is equal to weight of the object. Already we used this one. Normal force is acting upward direction, weight of the object is downward direction. So normal force is balanced by the weight of the object. N equal to mg into t, that is equal to minus mu. Here both sides mm get cancelled. T is equal to minus u divided by mu k into g. T is equal to minus mu k into g. So time taken by the body to reach point B position is nothing but a u divided by mu k into g. This equation we can write by using of the equation of the motion. First equation of the motion, how it is means v equal to u plus at. V equal to u plus at. Final velocity is 0 and initial velocity is u, and a equal to acceleration. Just now only we calculated acceleration is equal to mu into g. Acceleration is equal to mu into g. So mu g, if you write here, that is t, is into mu k into g into t. Then mu kg, if I am taking this side, this is actually plus I am written. Okay, mu kg is equal to minus u. Then t is equal to minus u divided by mu kg. Here minus indicate is nothing but a opposite direction, but time is a scalar quantity. So no need to write it is the modulus of the time we have to write, isn't it? We can get it is the u divided by mu k into g. This is nothing but a time. Both formulas are same. Body is in contact with a vertical surface. See, this is one vertical surface. Now I am taking one object like this. Just I am taking one object like this. At that moment, I am applying the force on a object is inside. When I remove this force, the object will move downward direction. The object will move downward direction. See here, how much force is required to? How much force is required to hold the object? To hold the object is like this. How much force is required to hold the object like this? See, in this situation, object is, when I am removing, when I am decreasing the applied force, the object ready to slide down direction like this. The object ready to slide down. Means, how many forces are acting on this body means frictional force. When I remove the force, the object cannot go upward. It will move downward only. At that moment, frictional force is acting upward direction. Frictional force is acting upward because frictional force is oppose the motion of a body. Frictional force oppose the motion of a body. Okay. Now, just I will show the diagram diagrammatically. Same thing. This is one block. This is one block. I am applying the force along this direction. Just I am applying the force. Applied force it is along this direction. At that moment, the block and object both are in contact. The block and object both are in contact. So normal force can be exist. That normal force is like this. Normal force is. Why I am writing like this means normal force is always perpendicular to plane of contact. What is plane of contact? This is the plane of contact. This is plane of contact. Plane of contact means where the objects, two objects are in contact, where two objects are in contact, that is called plane of contact. So this is plane of contact. Plane normal force is always perpendicular to plane of contact. See here, now these two are perpendicular. Normal force is always perpendicular to plane of contact. Okay. Normal force is acting along this direction. Applied force is acting along this direction. We are applying the force along this direction. Now frictional force. Frictional force, which direction it is acting? Upward direction. What kind of frictional force? Static, kinetic, rolling. Which kind of force? Now the object is rest or in motion. The object is at rest position. Rest position means static frictional force is acting. Rest position means static frictional force is acting upward direction, and weight of the object is acting downward direction. Weight of the object is acting downward direction. Now I am writing this equation. It is frictional force is balanced by the upward forces is equal to downward force. Upward forces is equal to downward force. What is upward force? Static frictional force is equal to weight of the object. Static frictional force is equal to weight of the object. Now the static frictional force, what is the formula? Mu s n into mu s n into mu s into n, that is equal to mg. Mu s into n is equal to mg. This is the static frictional force formula. This mu s is nothing but a coefficient of static frictional force. Mu s is the coefficient of static frictional force. Here, normal force is along this direction, force is along this direction. So at that moment, you can write N is equal to F. LHS said LHS force is equal to RHS. So N is equal to F. If I substituted in that one, mu s into F is equal to mg. Then F is equal to mg divided by mu s. F is equal to mg divided by mu s. Okay. In next situation, I am holding the object is like this. I am holding the objects in like this. How many contacts we have? This is one contact and this side is another contact. Two contacts are there. At that moment, how we can write the equation? See, one I am taking like this. Two objects. In these two walls, one object is here. One object is here. What is the force required? What is the force required to hold the object like that only? Means static frictional force for this surface is acting upward. Static frictional force is upward. See here, two frictional force. See here, frictional force between this surface and this surface is upward. Frictional force is this surface and this wall, it is nothing but upward. Weight of the object is acting downward direction. Weight of the object is acting downward direction. At that moment, you can write 2Fs is equal to mg. 2Fs is equal to mg because two forces are acting upward. Fs plus Fs, that is equal to Fs plus Fs is equal to mg. Now Fs is equal to what you can write formula, static frictional force is equal to mu s into n. So static frictional force is equal to mu s into n, that equal to mg. Now we know n is equal to F already. So F is equal to mg divided by 2 mu s. F is equal to mg divided by 2 mu s. If two objects are two surfaces, it is contact, mg by 2 mu s. If one surface is contact, you can write it is F is equal to mg by mu s. Okay. Now in second situation, third situation, see here, how much force is required? Minimum force is required. Minimum force, minimum F minimum force is required to move the object like this. Now the force object is like this. Minimum force is required to move the object from the bottom. Like this I am applying. What is the minimum force is required to move the object upward? Now the object is moving upward means, object is going upward means, what about the frictional force? Which direction? Is downward or upward? Object is going upward. Now frictional force, which direction it will be at? Frictional force will be at downward direction. So frictional force is acting downward direction. Kinetic frictional force is acting downward direction. Weight of the object is acting downward direction. Weight of the object is acting downward direction. So at that moment I am writing here F minimum is equal to mg plus Fk into F minimum is equal to here mg plus what is we are writing it is work done is equal to force into displacement. What is the work done to take a displacement? S means work done. F is nothing but a mg plus Fk because F minimum is acting upward, these two are acting downward direction. Yes, if you write here W is equal to mg plus Fk is nothing. What is Fk? Fk is equal to mu k into n, and plus s. Work done to move the object. Motion of a body on a smooth inclined plane. We are discussing about the smooth inclined plane. Find here. Just this is one inclined surface, this is one inclined surface. I am taking one object at the top of the wedge, at the top of the edge, without applying. It is a smooth surface. I am writing here, it's smooth. First case is the smooth surface. Smooth surface. First case one, it is the smooth surface. In this smooth surface, we are calculating acceleration of the block. Acceleration of the block, first one. Second one, it is the, when it is reached the ground, what is the velocity of the block? And third one, it is, what is the distance covered? What is the distance covered on the plane? And fourth one, it is time taken by the body to reach the ground from the top. So these four cases we are calculating in this situation. First one, I am writing here, this angle, it is the theta. This angle is theta. This equations here, first we have to resolve this one. Just the object is here. What about weight of the object is always vertically downward direction. Weight of the object is always vertically downward. Okay. What about normal force? Along this direction or along this direction or along this direction. Normal force is nothing but a perpendicular to plane of contact. Where is plane of contact? This is the plane of contact. Now perpendicular to this one. So normal force is always perpendicular to plane of contact like this. This is nothing but a force acting on a block due to the wedge is upward. Now force acting on the wedge due to the block is downward direction. According to the Newton's third law, for every action there is a equal and opposite reaction. So opposite reactional force along this direction I am taking. This is angle theta, means this angle also theta. These two angles are always same. Okay, mg can be resolved into the two components. One is horizontal component, one is vertical component. Here horizontal component is mg cos theta, vertical component is mg sin theta. Vertical component is mg sin theta. Horizontal component is mg cos theta, vertical component is mg sin theta. Okay, fine. See here, is there any opposing force? The object is sliding downward direction. The object is sliding downward direction. Now any opposing force is acting here? No opposing force is acting. So that's why I am writing here F is equal to mg sin theta. F is equal to mg sin theta, because just it is sliding. It's sliding like this. No opposing force. No opposing force. So that's why F is equal to, with the force F is equal to mg sin theta, it is sliding downward direction. Mg sin theta. According to the Newton's second law, F is equal to ma. Mg sin theta. Both sides mass get cancelled. Acceleration is equal to g sin theta. So acceleration of the block. Acceleration of the block, it is g sin theta. Okay. Next one. What is the final velocity? At the top of the position, I didn't apply any force on this one. So its own interest, it is moving downward direction. So initial velocity of the block is 0. Initial velocity of the block at the top. Initial velocity at the top is equal to 0. So initial velocity u is equal to 0 at top. Initial velocity u equal to 0. Now when it is touch the ground, see here, while it is moving downward direction, so it strike the ground with certain velocity. So final velocity at the bottom, final velocity is equal to v at bottom. Final velocity is equal to v at bottom. Okay. Now distance is equal to s. Distance is equal to s. Otherwise, distance is equal to l. From this point to this point, total distance it is travel. That is nothing but I am writing as a l. That is l. Acceleration already we calculated. A equal to g sin theta. A equal to g sin theta. Now I am equating v square minus u square is equal to 2s, third equation of the motion. Here final velocity is v. Okay, v. Initial velocity is equal to 0. to A equal to G sin theta and S is equal to L. So B is equal to under root of 2GL sin theta. What is the, when block is reach the ground, what is the final velocity of the block? 2GL sin theta. Okay. Now if you want to calculate distance, distance is nothing but a L. Just you can write in terms of the V square divided by 2GL. V square divided by 2GL. We can get like that. What is the tan? If you want to write the tan, V equal to U plus 8. V equal to U plus 8. Here final velocity is V, initial velocity is 0 and acceleration is equal to, we know it, acceleration G sin theta and time is t. Then V equal to G sin theta into t. Then V divided by G sin theta, I am taking this side, sin theta is equal to t, and this is the time taken by the body to reach the ground. This final velocity we know very well. 2g sin theta is there. Gg sin theta. If you want to substitute, you can modify this equation also. But T is equal to Vg sin theta. Okay, for your understanding, I will extend this equation for V is equal to, I am substituting it under root of 2gl sin theta whole divided by G sin theta is equal to T. Now, G sin theta I am writing as it 2gl sin theta divided by root G sin theta. Root G sin theta is equal to L. See here one root G sin theta get cancelled. Then T is equal to finally under root of L, it is 2L is remaining, numerator denominator 1G sin theta is G sin theta. T is equal to 2L and under root of 2L divided by G sin theta. If they given sin theta value, how we can write sin theta is equal from the diagram? Opposite side by hypotenuse. Sin theta is equal to opposite side by hypotenuse. Here opposite is nothing but a height of the wedge edge, and hypotenuse is the length of the inclined plane. Length of the inclined plane we taken as a L. So sin theta is equal to opposite side by hypotenuse. Sin theta is equal to opposite side by hypotenuse. Then you can substitute this value in all equations. Motion of a body on a smooth inclined plane. Now the object is going upward direction. Object is going upward direction on an inclined plane. See here, the object is just to be projected upward direction. We projected upward direction. At that moment, what is the acceleration of the block? Same first. Normal force, upward direction. Normal force is always perpendicular to plane of contact. Normal force upward and it is plane of contact, perpendicular. And weight of the object is downward direction. This angle is theta if you take it. And reactional force is along this direction. This is theta. These two angles are same. mg can be resolved into two components. One is mg cos theta. One more it is mg sin theta. One is mg cos theta. One more it is mg sin theta. Okay. Now the object is going upward direction. Along this direction. At that moment, F is equal to, I am writing ma sin theta, and F is equal to, this is mg sin theta because it is like this, mg sin, F is equal to Newton second law ma, and this one you can write as a minus F is equal to minus mg sin theta, because the object is going upward direction but it is acceleration, it is showing downward direction. Both are in opposite direction. mg sin theta minus mg sin theta. Here mass get cancelled. A equal to minus z sin theta. Here what is the minus indicate means acceleration is downward direction. Object is going upward direction. So when object is going upward direction, what is the acceleration direction is downward. Acceleration is nothing but a downward. That's why we are writing it is the minus g sin theta, isn't it? Okay. V square minus u square is equal to 2as. Now, what is the velocity? Now, the object is projected with a velocity u. When it is reached the top, its velocity becomes to 0. The object comes to rest position. While it is going upward direction, when it is reached the top position, its velocity will becomes to 0. Its velocity will becomes to 0. So, final velocity v equal to 0. Initial velocity is u. Acceleration is equal to minus g sin theta, and s is equal to l. S is equal to l. The distance is nothing but the length of the inclined plane, it is l. Substitute those values here. Final velocity is 0. U is equal to u square, and 2a equal to minus g sin theta into l. Okay, here minus minus get cancelled. U square is equal to 2gl sin theta, isn't it? So u is equal to, the object is projected upward direction with this velocity. The object is projected with a velocity, how much it is? U is equal to under root of 2gl sin theta. Okay. Next one, what is the time? Time means v is equal to u plus at. Final velocity of the block is 0. When it is reached the top position, its velocity is 0. When it is reached the, because it is projected upward, it is going upward direction. So when it is reached the top position, final velocity is 0, and initial velocity is u, and acceleration is equal to minus g sin theta, minus g sin theta into t. Minus g sin theta, I am taking this side. G sin theta into t is equal to u. What is the u value? U is equal to under root of 2gl sin theta, and this is g sin theta into t. T is equal to, I am writing here, 2gl sin theta whole divided by g sin theta, whole divided by g sin theta. This g sin theta I am writing as a, g sin theta I am writing as a 2gl sin theta divided by root g sin theta into root g sin theta. Just I am taking into root g sin, see a root I will in total, root g sin theta, root g sin theta. 1 g sin theta get cancelled. Then t is equal to, you can write under root of 2l divided by g sin theta. Time is equal to 2gl under root of 2l divided by g sin theta. Motion of a body on a rough inclined plane. Now we are discussing about rough surface, rough inclined plane, rough inclined plane, rough inclined plane. Okay. Now I am taking what surface? This is the rough surface. It is rough surface, isn't it? Now the object is sliding from top to bottom. The object is sliding from top to bottom. Again we are writing it is, this angle is theta. This is normal force. Normal force is always perpendicular to plane of contact. See, this is the plane of contact. Normal force is like this. Both are perpendicular. Okay. Weight of the object is downward direction, and this is the reactional force along this direction. This angle, these two angles are the same. mg can be resolved into two components. One, it is mg cos theta. One more, it is mg sin theta. One, it is mg cos theta. One more, it is mg sin theta. Okay. When object is sliding downward direction, isn't it? What about frictional force? Frictional force opposes the motion of the body. Kinetic frictional force is acting upward direction. Kinetic frictional force is acting upward. So here mg sin theta is acting downward direction. Kinetic frictional force is acting upward direction. Now this one we have to write here, resultant force is equal to downward force minus upward force. Here downward force is mg sin theta, upward force is equal to F. Now resultant force MA is equal to mg sin theta minus fk is equal to, I am writing here, mu k into n. Mu k into n. See here, what about the n? Normal force is acting upward direction. Quite opposite, what is the force is there? Mg cos theta is there. So this n is equal to, you can write n is equal to mg cos theta. Why we can write? Because the object is not going like this. The object is not moving like this. At that moment, upward force is equal to downward force. Upward force is equal to downward force. Substitute in that in this equation, MA is equal to mg sin theta minus mu k, n is equal to mg cos theta. See here, m if I take the common, ma is equal to g sin theta minus mu k cos theta. Mg I take the common, mg if I take the common, and mm get cancelled. Acceleration of the block, g into sin theta minus mu k cos theta. A is equal to g into sin theta minus mu k cos theta. Now the object is sliding downward direction. Acceleration of the block is equal to A equal to g into sin theta minus mu k cos theta. Okay. Now when object strike the ground, what is the velocity, final velocity? From the top, it is sliding downward direction. Initial velocity at the top position is 0. Initial velocity u equal to 0. Final velocity we are calculating is v, and distance s is equal to L. From the top to bottom distance is nothing but a L. Now we are writing it is acceleration, we know very well. From the equation, v square minus u square is equal to 2as. What is the final velocity? That only we are calculating. U value is 0. Initial velocity at the top position is 0. So initial velocity is 0. That equal to 2a. Acceleration is equal to g into sin theta minus mu k cos theta, and distance s is equal to L. We can write this equation square if you take that side, under root of 2gl sin theta minus mu k cos theta. This is final velocity of the block when block is strike the ground. So at that moment, what is the final velocity means? V is equal to under root of 2gl sin theta minus mu k cos theta. Now what is the time taken? Time taken by the body to reach the ground from the top. From here to here, what is the, from the top to bottom, what is the time taken by the body means? We are using first equation of the motion, V is equal to u plus at. Here initial velocity is equal to 0. A equal to, what is A? A equal to, already we calculated, g sin theta minus mu k cos theta into t. Okay, then this V is equal to, we can write here, g sin theta minus mu k cos theta into t. Then t is equal to V and divided by g sin theta minus mu k cos theta, isn't it? Here what is the velocity? This is the final velocity. This equation we are substituting in this one. At that moment, you can write here t is equal to under root of 2gl sin theta minus mu k cos theta divided by, this one I am writing as a root g sin theta minus mu k cos theta into g sin theta minus mu k cos theta. See here, this one I am writing as a root into root. At that moment, one root here, root g sin theta minus mu k cos theta is there. Root g sin theta minus mu k cos theta, one get cancelled. What are the remaining here? Just I am writing whole root. just I am writing root 2L divided by G sin theta minus mu k cos theta, sin theta minus mu k cos theta. This is the time taken by the body to reach the ground from the top to bottom. Okay. For example, if the block is moving upward, at that moment acceleration of the block is g into sin theta plus mu k cos theta. That minus will become as a plus. Here. Acceleration, simply no need to derive it again. A is equal to g sin theta minus is there now. So when it is going upward direction, we have to write that is the plus. We can prove this equation also, but directly we can write it is the acceleration is plus means. What about the final velocity? These will be changes at that moment. The time also will be changed. The time is equal to under root of 2L divided by G sin theta plus mu k cos theta. This is the time equation, and initial velocity equation will be here. Final velocity is there. There we upward direction means we can calculate initial velocity. That initial velocity means here minus will become as a plus. For example, previously I calculated smooth surface. Frictional force is 0. At that moment, frictional force is 0 means mu k is equal to 0. This one part if I taken as a 0, what is acceleration? G sin theta. Just to compare, that is equation. A equal to G sin theta only we got it. And here mu k is 0 means this part will become 0. Time is equal to 2L divided by G sin theta. Just previous class, all the formulas are same only here, but frictional force is 0. If smooth surface if you taken, mu k equal to 0. So if you can remember these formulas, you no need to remember that all formulas, because this mu k smooth surface means you can write frictional force is equal to 0. Frictional force is equal to 0 means these two only, G into sin theta only remaining. Here frictional force is 0 means under root of 2L divided by G sin theta.